Hello, this is my 373 assessment for graphs. We're going to start with traversals. Question 1, what features apply to this graph? I said that it was directed, as the vertices are very obviously directional. You can't go both ways between nodes. You can only go in the direction that the arrow is pointing. I said that it is cyclic and not acyclic because there is a point where the nodes loop. You can go from E to A to D and then back to E, or A to D and E and back to A. And I said that they are connected because all the nodes are attached by at least one edge to another node, but they are not strongly connected because you can't go from any node to another. There isn't a path between every node. Give the order that values would be printed in depth first search starting from A. For depth first search, you're going to start by going as far down a line as you can. So the results that I got were A, D, E, B, G, H, C, and F. You start at A, go to D because of its neighbors, A's neighbors. It is the highest priority or the smallest. So you go A to D to E and then to B. And then G is the next smallest, so you go to G, but it doesn't have any other neighbors that it can traverse further down towards, so you go to H. C is the smaller value between F and C, and then you finish off at F from C. In breadth first search, the answer would be slightly different. I got A, D, G, H, E, C, F, B. You basically start by looking at the neighbors that are next to your starting node. In this case, D, G, and H. D is the highest priority or the smallest, followed by G and then H. After that, E is the smallest of all the values that are connected to G or H. What I should say, actually, I'm sorry, is that D is the smallest of all of A's neighbors, so it gets first priority. And then E is next. That is the next layer, I guess you could say, of neighbors. After that, there's no neighbors for G that you can go down anymore, but there is for H. So you go to C, and then you go to F for H because it's on the same layer. Both C and F are 2 away from A, whereas B is 3. That's why you don't go there first. And so finally you go from E to B. So as I said before, the order is A, D, G, H, E, C, F, B. Here's some counterexamples. If we run DFS and BFS from the same start node in an undirected graph, the resulting DFS order and BFS order cannot be the same. This is an undirected graph with 2 nodes. If we start at node A, regardless of whether or not we use DFS or BFS, we're going to traverse the same path to B. And the same is true if you started at B. A minimum spanning tree in a weighted undirected graph cannot include the maximum weight edge. If there is only one path that you can traverse in a graph, then by necessity you have to include the maximum weight edge. In this case, you're going to end up with a total weight of 103. A weighted undirected graph cannot have more than one minimum spanning tree. In this case, you want to avoid the connections between A and C and A and B because those are both weighted at 100. D is connected to A, B, and C. So I've drawn a couple examples how you can go from A to D and then to C and then to B, or you can go A to D and then to B and to C. The weight is going to be the same. So it is a minimum spanning tree, a viable, unique minimum spanning tree. It's also worth noting that if all of these values, if you just had a square graph, and every value was worth 1, then starting at any point, you would be able to get a unique path